Hi everyone, today I'm going to be talking about flash column chromatography, also known as flash purification and medium pressure chromatography. This separation technique utilizes a compressed gas, such as nitrogen, or an air pump to push the solvent through the column. The principle behind this technique is the fact that different compounds in solution have different polarities. Therefore, using the same solvent will allow substances with different polarities to separate. So to get started, the two first major considerations are shown here. Number one, we have to consider the correlation of scale to the size of the column diameter and the volume of fractions. The scale, seen in the table here, is used to determine the column diameter, which is the diameter of the glass cylinder used for the chromatography. Next, we have to look at the correlation of RF of the target compound and the eluent, which is the solution moving through the column. The RF is the distance traveled by the desired compound divided by the distance traveled by solvent, and the RF should be around 0.3, allowing you to choose the appropriate solvent. Then we have to look at the column volume, which is 1 divided by RF. With a lower RF value, you can have a greater CV, meaning that the compound will have increased time in contact with the silica gel, allowing for greater chances of separation. So keep that in mind. Next, let's look at the physical setup for flash column chromatography. First, you measure a 6-inch mark up here. It will always be 6 inches as shown because if you need a greater volume, you choose a column with a greater diameter as seen in the last slide. Then you put a very small piece of cotton down here at the bottom and make sure not to pack it too tightly because this would inhibit eluent flow. Then you place a funnel at the top in order to pour a little layer of sand and then synthetic silica gel up to the 6-inch mark. Then you place another slightly thicker layer of sand in order to make sure the silica is not disturbed. The next step is to perform one wash with 100% ethyl acetate and then another wash with 100% hexanes. Now the volume of eluent is 10 to 20% larger than the volume of silica, so the chromatography is ready. So for our example here, we have a beta-carotene and chlorophyll mixture. This is green and yellow, respectively. And usually your solutions are not going to be colored, but this example was chosen specifically so that the chromatography could be seen better. When the chemical mixture is added, make sure to use a short pipette, as long pipettes often get stuck. You're going to pipette the solution in a circular motion around the sides of the column. Then you can add the gas pump or the compressed gas to the top using a clamp and turn it on. This will start the chromatography. Start collecting what comes out, known as the fraction, immediately after you start the gas pump. This is because nonpolar elutes will come out very quickly because they move through the column quickly. You have to switch test tubes every time one is filled or every time a different compound starts coming out. And you'll line them up here in the order that they were collected. Be careful not to let the column run dry. This is a very common mistake, but it could be very harmful to the results of your experiment. So always make sure that the level of solution is slightly above the sand and silica. So at the end of the chromatography, you're going to place an Erlenmeyer flask underneath and run one last wash with 100% ethyl acetate. This will push all the solvent out until the silica is completely dry. If you want to make sure that it's dry, you can also wait a couple of more hours before disposing it in the silica waste bin. This is usually done in a fume hood, but do as your lab directs you. At the end, with our test tubes of different compounds, we can identify those products using nuclear magnetic resonance spectroscopy, infrared spectroscopy, thin layer chromatography, or mass spectrometry. For a comparison model, we can think of flash column chromatography as sifting cocoa powder to make brownies. Just like in this separation technique, you have two or more end products, the fine powder and the chunks, and both can be used for something else. Neither is discarded because both are valuable. They also are both used to make another end product. Just like in chemistry, the products are often used for further analysis or other kinds of testing. Additionally, you can use different sizes of the sieve based on how much cocoa powder you have, just like you can use different diameters of column based on how much solution you want to elute. Flash column chromatography has a lot of applications. First, the major one is in synthesizing new molecules. In all synthetic reactions, there are going to be byproducts and unreacted starting materials that you need to filter out to get the stuff that you want. Therefore, it's very useful to take out the undesirable byproducts. Another common use is in forensic pathology, seen here. Forensic pathologists often use this separation technique to investigate ink samples from crime scenes. A third application is in the analysis of explosives. Explosives that are used in military and industrial settings have to be analyzed post-production to make sure their quality is controlled. This process can also identify both unreacted and post-explosive explosives. A fourth application is when you are making drugs. In the drug discovery process, chemists often derive natural products or chemical compounds with biological activity from natural sources to start making drugs. When extracting the biomass, the target will be extracted along with other unwanted substances. Therefore, you have to remove the impurity using flash column chromatography in order to move on and generate experimental results by individually testing the compounds. So, to sum up, the major advantages of flash column chromatography are that it's efficient, it only takes about 10 to 15 minutes, it's relatively cheap, and it's simple to do because there's no complex equipment involved. Thanks for listening. Hope you have a great day.